Have you ever just stopped and wondered how your body can go from a dead stop to a full-on sprint in a split second? Or, what's actually powering your muscles on mile 10 of a long run? Well, it's not magic, that's for sure. It's this incredible, high-speed set of energy systems. And today, we're going to unlock the science of how your body fuels every single move you make. Think about it. The energy you need for a powerful, explosive sprint versus a steady, grinding marathon, they are worlds apart. But your body, it handles both, and it switches between these energy gears in a blink of an eye. So how in the world does it do that? Well, the answer lies in this constant balancing act of energy supply and demand. Okay, let's meet the star of the show, ATP, or adenosine triphosphate. Just think of this stuff as the direct, rechargeable battery for every single one of your muscle cells. But here's the catch, and it's a big one. As you can see, your muscles only keep enough of this juice on hand for a few seconds of work. That means to keep moving at all, your body is in this constant, high-stakes race to recharge and produce more ATP. So how does your body solve this constant energy crisis? It does it with a really clever three-tiered system. You've basically got three different energy engines, and each one is designed to kick in for a very specific type of performance. Let's break them down. This table right here is our roadmap for the next few minutes. Just look at that top row, the creatine phosphate system. See under speed/duration, it says fastest. But, and this is key, it only lasts for a few seconds. That's our sprinter. Then in the middle, we've got anaerobic glycolysis, kind of like our middle distance runner. It's fast, but look at that tiny ATP yield. And at the bottom, that's the marathoner's engine, aerobic respiration. It's the slowest to get going, but just look at that massive energy payout. So first up is the system for that immediate, all-out, explosive power. I want you to think of the first few seconds of a 100-meter dash, or maybe one single heavy lift at the gym. This is your body's nitro boost. But that nitro boost is incredibly short-lived. This explosive power, which is fueled by that creatine phosphate system we just saw, it only lasts for about 15 seconds before it's pretty much tapped out. It's all about maximum force right now and nothing else. So how does it work so ridiculously fast? Well, your muscles keep a little stockpile of this molecule, creatine phosphate. And when you demand that instant energy, an enzyme basically acts like a pair of scissors, just snipping off a phosphate group to rapidly recharge one molecule of ATP. It is the body's ultimate quick charge system, and it doesn't need any oxygen to do it. But what happens after those 15 seconds are up and you're still pushing hard for the finish line? Your body has to shift gears fast. It calls on the second engine to keep that high-intensity effort going. So this next system, anaerobic glycolysis, it's like the bridge for high-intensity efforts. But that number right there on the screen, it tells you everything you need to know about its big trade-off. It's a really small energy return on your investment, just 2 ATP. Now, this slide shows a critical fork in the road for your body. This system breaks down glucose, and it creates a key byproduct, pyruvic acid. Now, if you've got plenty of oxygen, like you see on the left, that acid moves into our most efficient energy system. But, and this is what happens when you're going all out. When oxygen is scarce, your body takes a shortcut. It converts that pyruvic acid into lactic acid, just to keep churning out that fast ATP. You know that burning sensation you feel during really intense exercise? Yeah, that's linked to the buildup of lactic acid. But it's not the villain everyone makes it out to be. It's just the natural result of your body making a desperate gamble for fast energy when oxygen just can't keep up with the demand. Okay, so we've covered the lightning-fast sprint and the high-intensity minute, but what about the marathon? For any activity that lasts longer than a minute or so, from jogging to hiking, your body switches over to its most sustainable and powerful engine. And just look at that number. This is the aerobic respiration system. Compared to the measly 2 ATP we just saw, this pathway generates a massive 36 ATP from just one single molecule of glucose. Now that is what I call metabolic efficiency. This right here is your body's true powerhouse, the aerobic system. It can run on all sorts of fuels, glucose, fats, you name it, but it has one non-negotiable requirement, a steady, constant supply of oxygen. This all goes down inside the mitochondria, the power plants of your cells. And while it's a bit slower to get going, its incredible efficiency is why you can keep going for hours. And it's actually what's powering you right now, just sitting there watching this. All right, let's put it all together with this timeline. The first 0 to 15 seconds of an all-out effort, bam, that's the immediate power of the creatine phosphate system. From 15 seconds to about a minute as you're pushing through that high intensity, you're running on anaerobic glycolysis. And then for anything longer than a minute, the aerobic system takes the lead. The really amazing part is how your body just seamlessly blends these systems depending on how hard you're working. Okay, picture this. You just finished a really hard workout. You've stopped moving, but you're still bent over, gasping for air. Why is that? Well, you've just entered the recovery phase, and your body now has to settle a debt. This is called oxygen debt. And think of it this way. During that intense anaerobic work, your body basically spent energy it didn't have the oxygen to create cleanly. It took out a high-interest loan. Now that the work is over, you have to pay that loan back. And the currency your body demands is oxygen. So what are you buying with all that extra oxygen you're breathing in? Well, number one, you're replenishing those instant energy stores of ATP and creatine phosphate that you burned through at the start. Number two, you're cleaning up shop, converting that lactic acid back into something usable. And number three, your heart is still pumping, your body temp is high. All that extra oxygen supports those elevated systems as they come back down to normal. That's why you're breathing hard long after the work is done. And this all brings us back to that feeling of muscle fatigue. As this quote suggests, that lactic acid buildup is a key factor. In simple terms, it makes the environment inside your muscle cells more acidic. And that change in acidity messes with the complex chemical machinery of muscle contraction, making it way harder for your muscles to fire effectively and powerfully. So, whether you're training to be a sprinter, a middle-distance runner, or a marathoner, you now know exactly which engine you're using. You get the instant burst, the burning minute, and the long-haul aerobic powerhouse. So the real question is, now that you know what's happening under the hood, how are you going to train and fuel your body to get the absolute most out of every single movement?